Hello friends, welcome to my channel. Today we're going to talk about the aldol condensation. So before we should move ahead, we should know about what is aldol and what is condensation. The name itself tells us aldol combination of the aldehyde, that is this group, plus alcohol, that is this group. So there is something combination of the aldehyde and alcohol, and what is condensation? Removal of water. So this is a just basic idea regarding the aldol condensation. So let's move in further and let's understand what is aldol condensation in detail. So this lecture or this topic will be covered into the three parts. First, general reaction will be considered here. Then what is happen in mechanism, that is a two-step mechanism, will be discussed in this whole topic. So let's begin with it. Okay, so here is what aldol condensation and definition is here. So what is definition of the aldol condensation is front of you. So an aldol condensation is a condensation reaction in which organic chemistry in which enol or enolate ion is react. So what is exactly enol and enolate ion? So when you consider this definition, there is must be understand what is this enol and the enolate ion. So enol, that means alcohol plus ene is there, that is alkene. So what is this exactly? C double bond and OH is there. This is a enol. And when you talk about the enolate ion, that means this H replace here. So what is going to happen? CH double bond C and O minus. That is charged over here. That is called enolate ion. So let's talk about further the organic chemistry in which an enol and enolate ion. We will study in detail what is enol and enolate ion further. The formation of what? Beta-hydroxyaldehyde or beta-hydroxyketone. What is exactly this also? So we are going to talk about this part and this part in further slides in detail. So what is the condensation? Means aldol condensation is what? Condensation reaction in which what is the formation? Enol and enolate ion reacts with the carbonyl compound to form what? Beta-hydroxyaldehyde and beta-hydroxyketone, followed by the dehydration to give the conjugated enone. Okay. So let's discover or let's understand into the specific manner when you talk about this reactions. Okay, so let's move further. Okay, so we have considered here what is enol. So what are the enol? The enol, a molecule which has a hydroxyl group, that is what OH group, is directly bonded to an alkene. Means what? Carbon-carbon double bond is there and is attached to the OH group. It is called enol. That is enol stand for alkene is there and OH, that is alcohol there. And what is ion? Enolate ion is here. So what is that? See here. If I draw the structure like this, carbon-carbon double bond is there. This is alkene, but one of the carbon has attached with the OH. It's called enol. A molecule which has a hydroxy group directly bonded to the alkene. So this is enol. So you can see here, CH2 is here. It has a negative charge. As oxygen is highly electronegative, so this bond, this is a pi bond, which one bond will be shift here because this is highly electronegative. So as it moves here, this definitely will be here. So there is a formation of double bond between this carbon and carbon that we have considered here, and there will be charge. So this is enol and this is enolate ion is there. So this is the exact knowing or exact understanding of the enol and enolate ion. So what is the further thing that we have to consider? That is beta hydroxyaldehyde and beta hydroxyketone. So what's that exactly? Let's see here. Okay, before me moving ahead, we should know this also. In case of when this is what ketone in case of base will be forming the enolate, and in case of acid will be formed enol. So we will discuss in later on, but this is just a slide which tells about in case of base and acid how they react. Now let's talk about the beta hydroxyaldehyde. What is beta? Before that, we should know what is alpha and beta. Suppose this is a carbonyl group. Okay, so this is your carbonyl group. The carbon adjacent to the carbonyl group is called as alpha. The next carbon is called as beta. So what is that? Where is a function group? Any function group, the next to the next carbon to the function group is considered as alpha, and apart from that or next to that carbon is called beta. So alpha, beta, gamma will be there. So this is a numbering system that we have to understand. That is a beta. So tell me one thing, this is your function group, this is your alpha, and this is your beta carbon. So student, why we don't consider this as a function group? Yes, we have to consider this as a function group as well, but ketone is sorry, this is aldehyde here because H is there. So aldehyde and hydroxyl is there. So aldehyde is what considered as a priority one. So that is why this is a function group, that is a carbon. The next carbon, which is what alpha, and next carbon, which is what beta. So this is called beta hydroxyaldehyde. So what we have studied, aldol condensation, where we have to understand what there is a reaction of enol to form beta hydroxyaldehyde or ketone. So this is a reaction. This is general. We just have to seen up till now. So let's move in detailed manner. What is exactly the general reaction? Now, before we should move ahead, we should know about the requirement of the aldol condensation. First, as we mentioned, the function group next to the carbon is considered as what? Alpha carbon. Okay, this is considered as what? Alpha carbon. So, a molecule, and this is alpha carbon. So, hydrogen attached to this carbon will be considered as alpha hydrogen. Have you understood that? Again, I'm repeating. This is a function group or carbonyl group. The carbon which is attached here is called as alpha carbon. The hydrogen which is attached to this carbon is considered as what? Alpha hydrogen. So what is the first requirement? A molecule that has a carbonyl carbon hydrogen bond next to the carbonyl group. That simply means this. So whenever there is a structure like this, next carbon, which is this carbon, which is next to the carbonyl group, having the hydrogen. So can I say in a simplified manner, where there is a presence of the alpha hydrogen, there only or then only the aldol condensation will be occur. Okay, there is a cross aldol condensation also, but we are studying right now only the aldol condensation. Second, a molecule that has a carbonyl group, the first molecule is called an alpha hydrogen. So what is the prior requirement? Alpha hydrogen should be there. So let's consider here CH3, C double bond H. So can you tell me what is the alpha hydrogen here? This is a carbonyl group. Next to this is carbon and hydrogen attached. So this is having the alpha hydrogen, and this is fulfill the requirement. But in this case, suppose I'm considering this is a ketone. Here is also alpha hydrogen present, and here is also alpha hydrogen present. So it's also fulfill the reaction. But in this case, formaldehyde, the reaction will not occur because there is no hydrogen is there. But what we want, alpha hydrogen. What is alpha hydrogen? A hydrogen attached to the carbon, which carbon is next to the carbon group. So here is no carbon present, so it not undergo or not follow the aldol condensation. So up till now, what we have studied, the requirement. Now let's study the exact mechanism. So general reaction, we are considering the general reaction here. So what is the general reaction? Example is what? Acetone. Okay, now tell me one thing. Do this structure possess alpha hydrogen? Yes, definitely, because this is a function group, and next to carbon have a hydrogen, that is a what? Alpha hydrogen. So this is acetone that we have considered. Now in presence of NaOH, what is this? OH minus in presence of what? In short, base. What going to happen? Aldol condensation occur, and there is a formation of beta hydroxyketone. Why beta hydroxyketone? Why not aldehyde here? Because this is a respective beta hydroxy structure will be formed. Right now, this is a ketone, so that's why it's beta hydroxyketone. If there is aldehyde, it forms beta hydroxyaldehyde. Now, look at this structure. This O is there, CH3 is there, OH is there, and here, if I draw a hydrogen, what is the condensation? So, what is aldol happen? That is aldehyde plus alcohol or enol form. But what is the next step? That is the condensation. What is condensation? Removal of water. So from where water is removed? So this OH molecule and this H molecule, that is also alpha hydrogen here considered. So this and this molecule remove the water. As there is a removal of water, definitely this bond shift here and this bond shift here. So there is a formation of pi bond, that is a double bond. Okay, so this is undergo NaOH, or you have to just simply heat it. So what happened here? What is the formation? Alpha beta unsaturated by alpha. This is alpha. Next is beta. So alpha beta. What is there is a formation of double bond whenever there is a removal of water. So that is considered as what? Alpha beta unsaturated ketone, and it also considered as enone. So we have studying here enol structure is formed and enone structure is formed. Okay. So what is happening in general? There is a aldol reaction whenever alpha hydrogen is present. In case of basic condition where beta hydroxyketone is formed, the next step removal of water takes place from the alpha hydrogen and beta OH molecule. So there is a formation of what? Double bond. This is a general reaction. Now let's study exactly the mechanism. So when you talk about the mechanism, definitely you have to consider a two-step mechanism here. Why? Because formation of aldehyde, aldol reaction first, and then condensation, that is removal of water. So it followed by the next step. So what is exactly? Let's see. Now first mechanism, that is the first step mechanism, is this. What is that first step mechanism? Let's see. Acetaldehyde. What is here? Acetaldehyde is there, and OH minus base. From where is OH minus come? We have a basic condition. So that is OH minus has come here. So this OH which takes place what? This is alpha carbon because it's next to the carbon group. And this hydrogen will taken up by this OH molecule. Again, I'm repeating. This is OH and this OH. This is come from the base. So it taken up the alpha hydrogen, remove it. So there is a formation of charge, or which charge? It's called a carbanion. Why carbanion? Because the negative charge on the carbon, that is why it's called carbanion. Have you understood? So whenever there is a removal of hydrogen or taken up by the base, there is a formation of charge on that particular carbon, which is next, or we can say this is alpha carbon. Okay, but it undergo the see, what is arrow? It indicate stabilization, or we can say there is a interconversion occur. So this charge will be not forming here. So this charge will taken up by this oxygen. Why? Because it's highly electronegative and it requires the electron. So what is happening here? This charge electron moves here and this bond moves here. So there is a charge occurrence on the oxygen, and there is a, as electron is moving here, there is a formation of double bond between carbon and carbon bond. So this is called enolate ion that we have studied. And water is removed. How water is removed? OH, H, H2O. So you have to consider what is the first step mechanism we have studied. Again, I'm repeating. The base which is active take up the hydrogen from the alpha carbon. As the alpha hydrogen, there is no alpha hydrogen right now, so there is the appearance of the charge on the carbon. So there is a carboanion formation. As there is a negative charge, for the stability purpose, it goes, as the oxygen is next, it attracts that electron and it forms the double bond in between. But what is the exactly meaning of this box? That is, this is a intermediate. Okay, this is what intermediate. So what we are considering here, carbon having double bond attached to H, and this carbon having a negative charge right now. So this is into the picture we have to consider. So let's move to the another set of mechanism, that is next mechanism. So what is that exactly? Let's see here. So this is a second mechanism where what happened? There is a formation of negative charge on this particular carbon, that is enolate. Now this was the first molecule of acetaldehyde having right now what? Positive charge. So this going to attack. Now this is act like what? Nucleophile. As it is act like a nucleophile, definitely it's going to attack on what? This carbon of the, or we can say this is a second molecule. So whenever having a negative charge, now this is a nucleophile, nucleus loving, so it's going to attack on this particular carbon. As it's attack on this particular carbon, what happened? There is a formation of bond between this and this carbon, and the one bond gets shift on the oxygen, which is highly electronegative. So what has happened? There is a formation of negative charge. See here, if I draw again here, this is a structure CH2 minus simply. and this is going to attack on the this molecule. So what going to happen? I'm using the red pen here to understand this part is attacking on what this. So can I draw the structure like this? CH, C double bond O, CH2. Now it's form bond with whom? It's form a bond between this carbon I'm talking about. So H will be upside, CH3 is there, and O, which is there is a shifting of bond that we have understood here. What happened? O negative will be there. So have you understood that? Okay. So there is a formation of negative charge on the oxygen right now. But we have understood that this is what nucleophile attack, that we have understood why nucleophile, which is nucleophile, enolate and act like a nucleophile right now. So there is a H2 water, that is a basic condition. We know that water is from what? OH. This is O minus, which attracted H from the water molecule. So it will be from the OH over here. Have you understood that? Now OH is here present. Now what going to happen? This is alpha carbon. This is beta carbon. So this is aldol product is formed. What is the next step? Next step is what? Removal of water molecule. So from where ideally water molecule can be removed? This from the beta OH and from the alpha this H. So there is a formation of what? There is a formation of double bond between this carbon and this carbon. Again, I'm repeating what is going to happen. This OH and this H, that is alpha H and beta OH, will be removed, and there is a formation of double bond between this carbon. So there will be formation of which product right now? C double bond C. That is, I'm talking about this part. Having H attached here, CH3 is here, this having H, and one bond having what? C double bond H. So this is a condition here. Again, I'm repeating with a particular manner. See here. If I remove OH and this H, there is a formation of double. So let's draw here again for the simplified manner. C, it will be H, C double bond, H will be here. Here is a formation of double bond. H will be the same, CH3 will be the same. So this is what? Alpha beta unsaturated ketone. Okay, so this is the end product of what? Aldol condensation. What is the first step we have considered? Formation of enolate. Then there is a nucleophile attack of that enolate ion on the second molecule of aldehyde or respective ketone. Then there is a removal of water molecule from the aldol product. So this is, we have to understand the aldol condensation. So I hope every step is clear, crystal clear in front of you. Okay, so let's study for next. So what we have understood? See, again, I'm going back to the definition point of view, because we just discussed what about the mechanism. So what is aldol condensation? Aldol condensation is a condensation. Obviously, removal of water should be there. But what is reaction? Reaction is happening between whom? Enol. And how enol is formed? There is a negative charge on the carbon, which is next to the carbonyl group. As there is a negative charge, it acts like a nucleophile, which attack on the second molecule. So what is the requirement? The structure should contain alpha hydrogen. That is the first requirement. And second requirement is what? We need a two molecule, same molecule, that is two aldehyde or two ketone should be there. So this is the reaction of the aldol condensation that we understood. Okay, then what is happening? If there is a reaction between two molecule, what is happening? A beta hydroxyaldehyde and beta hydroxyketone is formed. So what is beta hydroxyaldehyde? Suppose this is function group, this is alpha carbon, this is a beta carbon. Okay, this is beta hydroxy. What happened? Ketone is there. But what is the next step? Third step is what here? And third step is what? OH is removed and H is removed from here. So there is a formation of alpha beta unsaturation. ketone is there or respective aldehyde is. Okay, I hope you are understood this. Okay.